So welcome to the second segment of the video, photoelectricity. Okay, so we're looking at the past questions now. So we are told that number one, calcium has the work function of this value. We have to find the maximum energy of liberated electrons when it is illuminated by lights of this frequency. Okay, then we are given these options. Now, what do we know from this question? What can be obtained from this question? What are the values that we know already? So what we know right now, you can see that we have the work function is in the question. This is the work function here. Then we have the frequency, which is this value here. So we have the frequency and the work functions. And then what are we looking for? What are we trying to find? We're trying to find the maximum energy is given by the kinetic energy. So we're actually looking for the kinetic energy. Then we need to use the formula that connects kinetic energy to work function and frequency, which is Ke is equals to hf minus work function. So this is the formula to use. And h is Planck's constant, which is this value here. So we already have the Planck's constant. So we just multiply that by the frequency. The frequency is this value here. So you have Planck's constant times frequency minus work function, which is given in the question. So if you multiply these two together, these two, we get 44.22 times 10 to the power minus 20. Then you subtract 3 times 10 to the power minus 19 from it. So you get 14.22 times 10 to the power minus 20 when you subtract that. But this answer, this particular answer is not in the option here. You can see it's not there. So you have to come back, convert this 14.22 to standard form. That will give you 1.422 times 10 to the power 1. Then times 10 to the power 20 minus 20, which is this second part here. Then use the law of indices. So the base is the same. You just add the powers. So 1 minus 20, that will give you minus 19. So the final answer is 1.422 times 10 to the power minus 19 joules, which is actually option A. Okay, so that's how to solve the question. I hope you understand. Now let's move to the second one. So that if the threshold frequency for tungsten is 1.3 times 10 to the power 15 hertz, that's the threshold frequency, that's F0. What is the work function? So we have to find the work function. Okay, so what do we know? Let's check what we know. From this question, we have the threshold frequency. It is given by 1.3 times 10 to the power 15 hertz. So the symbol for the threshold frequency is F0, which is right here. Now, what are we trying to find? We're trying to find the work function. You can see what is the work function. So we're trying to find the work function. Then, what formula are we going to use? Work function is equals to hf0. Don't forget that. Work function is equals to hf0 or h times f0. And you know your h is Planck's constant, which is given by 6.6 times 10 to the power minus 34 joule seconds. So this is the Planck's constant. Multiply that by the given frequency in the question. Okay, by the time you multiply these two, you have 85.8 times 10 to the power minus 20, which is not in the option here. So you need to convert this to standard form. So 85.8 to standard form is 8.58 times 10 to the power 1. Then you now multiply that by 10 to the power minus 20. So at the end of the day, you have work function is equals to, this is indices here. You have the same base, just add the powers. So you have 8.58 times 10 to the power minus 19 joules, which is actually option B. So 8.58 times 10 to the power minus 19 joules is the given answer. Third question, we are told that the maximum kinetic energy of the photoelectrons emitted from a metal surface is 0.34 electron volts. So EV stands for electron volts. If the work function of the metal is 1.83 electron volts, we have to find the stopping potential. Then we have these options here. Now, what do we know from this question? Let's check. So from this question, we have the kinetic energy. Okay, we have the kinetic energy, which is this value here. Kinetic energy is this value here. Then the work function, we have it in the question. Work function is 1.83 electron volts. Now, we are looking for stopping potential. Stopping potential is Vs. That's what you are looking for. Find the stopping potential. So stopping potential is what you're looking for, which is Vs. Now, the formula to use is Ke is equals to EVS. Okay, each one of the formulas for stopping potential. Kinetic energy is equals to EVS. So what you're going to do is just look for the kinetic energy and equate it to EVS. That means we're not going to use the work function, which is given in the question. This value is useless. So we just equate 0.34 electron volt is equals to EVS. And don't forget that the value of E is the electronic charge, which is given by 1.6 times 10 to the power minus 19 coulombs. So you have E on the left hand side and you also have E on the right hand side. This V here stands for volts. So this E and this E will later cancel out when you make Vx instead of the formula. So you have 0.34 EV divided by E. So E will cancel out and you have 0.34 volts. So the kinetic energy is actually equals to the stopping potential. Okay, the kinetic energy is equals to EVS. Now answer is 0.34 volts, which is option D. Okay, so let's move to the next one. Of a photon and its wavelengths are related by E lambda equals to X. The numerical value of X is, then we're given these options. So we are given the Planck's constant and the speed of light. Then this Y is lambda. So this actually E lambda equals to X. So let's look at what we know from the question. There are no numerical values in this question, but we are given the Planck's constant and the speed of light. So we are looking for the value of X. But the formula to use is E equals to HF. But we also know that E is also equals to HC over lambda. This Y here stands for lambda. So when you cross multiply from here, E is equals to HC over lambda. If you cross multiply, you will get E lambda or EY is equals to HC. This HC is what is standing as X here. So you're actually looking for the value of HC. And you already have your H in the question, Planck's constant, and you have C, which is the speed of light. So just multiply the two. Whatever you get will be your final answer. So you have H here, which is 6.6 times 10 to the power minus 34. Then multiply that by the speed of light, which is 3 times 10 to the power 8. Multiply that, you will get X equals to 1990 times 10 to the power minus 28. Okay, so you convert this 1990 to standard form. That will give you 1.99 times 10 to the power 3. Then when you use indices, you can add this one with indices. That's 3 plus minus 28. That will give you minus 25. So at the end of the day, you have 1.99 times 10 to the power minus 25, which is the option B that is there. So you can see it's very straightforward. Okay, you're actually looking for the value of X, and X is the value of HC. So you just multiply the Planck's constant by the speed of light, and you will get your answer. So in this question, we are told that light of energy 5 eV, which stands for electron volts, falls on a metal of work function 3.0 eV, and electrons are emitted. You have to find the stopping potential. So you are given the value of the electron volts, electronic charge, which is 1.6 times 10 to the power minus 19 coulombs. So what do we know from this question? You can see we have the light of energy 5.0 eV. That means the energy of the incident light is 5.0. Then we have the work function from the question, which is 3.0 eV. Now what are we looking for? We're looking for the stopping potential, which is Vs. So which formula are we going to use? First of all, you must find the kinetic energy. Don't forget the kinetic energy is equals to the stopping potential multiplied by E. So kinetic energy, first of all, that's the first thing to find. So we're going to use Ke is equals to E minus the work function. So we already have E in the question. E is 5.0. So 5.0 minus work function, which is 3.0. So that will give us 2 eV, electron volts. So the kinetic energy is 2 electron volts. But relationship between kinetic energy and stopping potential is given by Ke is equals to EVS, where E is the electronic charge. So by the time you make Vs separate the formula, you're going to have Vs equals to Ke divided by E. And from this question, our kinetic energy was 2 electron volts. So that's divided by E. So that will give you 2 eV divided by E. So E cancel out. You're going to have 2V, which is 2 volts. So the stopping potential is given by 2 volts. Okay, 2 volts. So the answer is B. Okay, so let's move to the next one. So in photoelectric emission, the number of electrons ejected per second depends on the dash. So intensity of the beam, work function of the metal, threshold frequency of the metal, and the frequency of the beam. So the number of electrons, though it cannot be known, but the number of electrons that will be emitted depends on the intensity, okay, of the beam. It doesn't depend on work function of the metal, threshold frequency, or frequency of the beam. It depends on the intensity, how strong the light is, the light incident on the metal, how strong it is. So that's the intensity of the beam. So the answer is A. Then for the next one, the threshold frequency for photoelectric effect depends on the, so threshold frequency for photoelectric effect depends on the dash. So you are given frequency of the incident light, intensity of incident light, PD between cathode and anode, and material of the photocathode. So for this question, you're looking for F0, which is the work function. each material has its own work function. So F naught depends on the work function of the material. Okay, whether you're using zinc, you're using iron, or you're using another kind of metal. So it doesn't depend on the frequency of the incident light or of the intensity of the light. It depends on the kind of material you're actually working on. So each material has its own threshold frequency. So the correct answer is material of the photocathode, or material of which the cathode is made of. So that brings us to the end of the video. If you really enjoy this lesson, give it a thumbs up, like, subscribe, and share with your friends. Also, I really appreciate you guys for watching up to this point. Okay, thank you for watching. I'll see you guys in the next one. Don't forget to subscribe to the channel. Bye.